Hi, I'm Andy, welcome to Narcolepsy Pumpkin. If you haven't done already, why don't you click on subscribe and click on the bell. That way you'll get notifications about new videos when I post them. What I want to do is run through solid principles in probably the shortest time possible to give you a kind of reference material that you can come back to at a later date. The single responsibility principle is loosely based on the original common closure principle, which is basically grouping things together that change for the same reason. So we could pull that down into the code as we go down. We try and make classes that will change for just one reason. We try and make functions that just do one thing. Each level of your code should have one responsibility. Open close principle. So we're looking to be closed to change but open to extension. What that means is, in essence, by using object-oriented techniques, we can use abstractions to allow ourselves to have an interface we will not change, but allow the implementation to be extended and moved on. At least that's my interpretation of the open-close principle. Liskov's substitution principle. With this principle, we are looking to make sure that derived classes, i.e. things that inherit from other classes, are interchangeable with their parent, so you can swap them out without any damage or any change in behaviour to your application. Things like implementations to databases, your code should be absolutely agnostic about how data is persisted. That's where Liskov's substitution principle would come into effect. You'd have a different implementation of a database persistence, but your code doesn't care which one it's using. So you can swap them out and they all behave in the same way. Interface segregation principle. The ethos of that is making sure that you're not forcing things that code doesn't depend on to carry along for the ride. Where you've got large data objects or large classes, those can probably be split down into multiple interfaces. You may still keep the implementation exactly the same, but you're inheriting from multiple interfaces. But it does allow the things downstream to only depend on the parts of that they actually need. Dependency inversion principle. Essentially, we're looking to have the software source code dependencies opposing the flow of control. And we do that by depending on abstractions as opposed to concretions. So the principle in itself, you should really look to have abstractions depending on abstractions, absolutely not having abstractions depending on any concretion. The only exception to that is probably things that are part of the framework. So in C#, things that are actually in the framework, it's sometimes very difficult to abstract those out. So depending on those within an abstraction is okay. Higher level modules shouldn't depend on lower level, or vice versa. Everything should depend on abstractions. If you put your abstractions in a common place, that means that all the dependencies go to the abstractions and there's no actual concrete links between your objects. So that's a run through of solid principles in a few minutes.